Good morning, everyone. Today, I would like to introduce you capacitors and its application in the industry. In this course, you will learn what is capacitor and its application in the industry. I will teach you the physics behind the capacitors and the use of a capacitor in electric circuit and electronic boards. Then I will introduce you some important parameters related to the capacitor, for example, capacitance and how to calculate capacitance for different capacitors with different shape and size. And at the end, you will learn how to find the equivalent model for capacitors. For example, in parallel or series form and or in a combination of parallel and series. The course material are collected from the book named University Physics with Modern Physics, written by Hoag and Dr. Young. You can find this book in the library or you can buy it through the internet. Okay, what is capacitor? Capacitor is a component that can store electrical energy in the form of an electric field. As you can see, a capacitor is consists of two parallel conductive material, which is a isolation placed between this conductive material. It doesn't need to be parallel; it can be in a form of different shapes. Sorry, and when we connect a capacitor, the isolation between this conductive material can be vacuum, air, it can be glass, it can be ceramic, and so on and so forth. When we connect a capacitor to an outside voltage source, for example, a battery, the negative side of battery repel the electron and follow them in the connected circuits. So these electrons accumulated in one plate and create the negative charge plate. And the negative charge plate consequently repel the other electron from the other plate and create the positive charge plate. This negative and positive charge make the electric field and a corresponding voltage, which this corresponding voltage across these two plates resist with the voltage that the moving electron in, and at the end these two voltage become equal and stop the electron flows. In the physics, we show this electric field as an arrow from the positive charge plate to the negative charge plate. So we show the charge plates with Q and with the sign of positive and negative, and also arrows shows the direction of electric field by the contract is from the positive to the negative. Yeah. Capacitor and capacitance in principle are similar, but with some differences. For example, the storage capacity in a battery is much bigger than a capacitor, while charging and discharging speed in capacitor is higher or faster than batteries. And the form of energy in stored in capacitor is in electrical field is in electric form, while in battery we have a chemical energy. In the industry, you can find capacitors in different form and shape and size. Here you can see different pictures of capacitor. We have ceramic capacitor, they are look like linseed, or we have cylindrical shape capacitors like electrolytic capacitors. We have primer capacitors, time varying capacitors, or variable capacitors, which we can change the capacitance of a capacitors. In the industry, you will see that capacitors are widely used in electronic circuits or electrical circuits. We use them mainly for flattening out the power stream in capacitor. For example, in this animation, you can see when we don't have capacitors, whenever we switch the keys, the light is switching. But when we connected it to a capacitors, this capacitor can provide a more stable um, power, as it can flow down this fluctuation in the power source. We use the capacitor for improving power factors or for soft starting of induction motors. In electric circuit, we show the capacitors with the following symbols. I show for example, the UK symbol and the US symbols, which is two parallel line connected to the two wire. And here you can see non-polarized capacitors against polarized capacitors. For the polarized capacitor, there is a positive sign on top of one of the plate, which means this part must be connected to the positive side of an outside voltage source. In the formula, we show the capacitor with a C. One of the main important parameters in a capacitor is capacitance. Capacitance is the capacitor's ability to store charge, ability to store charge and form an electric field. It's a metric that shows how much energy we can store in a capacitor. Here you can see this information on a real capacitor. The unit is farad and it expressed by the ratio between the charge electrons over the voltage across the capacitor's plates. Normally, the capacitance is range from the picofarad to microfarad or millifarad, but 1 farad is a huge amount or is a big amount, which can be a very big size of capacitor, and we don't use a 1 farad capacitors in industry. Thank you so much for your attention.